Hi, my name is Paul. The purpose of this video is to demonstrate basic competency in using Apache Structured Streaming API. This presentation will cover 4 main steps. Number 1, create database. Number 2, generate transactions. 3, compute and store aggregate transactions count. And finally, to plot the real-time graph. To start off, I will create baked-in database in MySQL. Click on MySQL Workbench icon to start MySQL server. Run the Create Database Baked-in query as shown. Check that the database is created. Next, I will create the AGG trans table to store aggregated data points for plotting real-time graph. Click on Jupyter Notebook icon and create a new Python notebook. Copy the Python scripts from create agg trans tbl.py file and paste onto the empty cell in Jupyter Notebook. Run the script. Switch to MySQL server and confirm that the table is created. Run the select asterisk from baked-in.agg_trans query as shown. The output shows that the table is empty. Once the database is created, I will run generate_transactions.py to periodically spew out log files of customers' transactions into a folder in c:\baked-in/transactions folder. Before I run the generate transactions.py script, I will show you this script in Windows Notepad. Now go to Windows command prompt, run Python command, Python generate_transactions.py. A continuous listing of transactions generated by the program will be displayed until Ctrl+C keys are pressed. Now switch to Jupyter Notebook screen to run the insert data to _agg_tbl_v2.py script. Click on plus icon to open a new cell. Copy the Python script from insert data to _agg_tbl_v2.py and paste onto the empty cell in Jupyter Notebook. Run the script. Click on Jupyter Notebook icon to display the notebook console. It will take a minute or so for the application to start computing the aggregate data and to output to database. Now that the application is running, I will switch to MySQL database screen to check updates in agg_trans table. As you can see, the agg_trans table is now populating with data. Once agg_trans table is being populated, I can run bargraph_v2.py to generate the real-time bar graph. Open the command prompt as shown. Run Python command python bar-graph_v2.py. Then right-click on Google Chrome icon as shown and select New Window. Type URL as 127.0.0.1:8050 to view the real-time bar graph. As you can see, each bar has an interval time of 1 minute from each other, which corresponds to the time window period of 1 minute. As more aggregated data are stored in the database, the bar graph will reflect the real-time changes based on the updated data. Through this video presentation, I have demonstrated basic competency in using Apache Spark's structured streaming API. Details on procedures shown in this video presentation can be found in my document step-by-step tutorial, which is submitted as part of this assignment. I've come to the end of my video presentation. Appreciate your time spent to view it and hope you like it. Have a good day and thank you.